Evans, Chapter 5, Problem 2. Consider the experiment of drawing two cards without replacement from a deck consisting of only the ace through 10 of a single suit. For instance, only hearts or only clubs, only diamonds. The first question says, describe the outcomes of this experiment. List the elements of the sample space. Okay, so the first thing we just need to do is delineate what are the possibilities here, the possible outcomes. We'll start with card 1. You pull a card 1 and then you pull a card 2, so it's selecting cards without replacement. It's not like you're sticking it back in there and shuffling it, okay? So we could put this in here as, for card 1, we can start with the ace, as if we pulled the ace first, because ace is face value of 1. We're going to use the numeric values for each of these cards, okay? So if you pull an ace out of the deck the first time, there's 9 possible ways that you could pick that and then another card. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 there. Your second card could be a 2, a 3, all the way up to a 10. So we're just defining the space here of all the possibilities that we have. We can't pull an ace because we already pulled the ace. Okay. Now, if you pick card 2 first, there's 9 possibilities. There can be a 1. You can pull an ace, but you can't pull another 2 out of the deck, so it'll be a 3. Pick a 4, and go all the way down to 10. Once you pull the 2, you can pull a 10, all the way up to 10. And what we do here is we're just going to repeat all of this for each of the cards. So to make it easy, this is just a little trick I'm doing here to be able to know where to put the 3s. There's 9 possibilities after you pick a 3, 9 possibilities of what you could pick as a second card. Four. 5. 6. 7. And finally 10. 10's our highest face value. Okay, but now we have to fill in the rest of the chart here for possible outcomes. This takes a little bit longer, but I'm going to start cutting and pasting here, so it should go a little faster. So 3, we can pick 2, and then we can pick from 4 to 10. Have to include the ace. So we're completing our chart here. And almost there. Got it. Now we have our chart done. Okay. So A says describe the outcomes of the experiment. We just did that. Okay, that's what we just did. A is columns A and B in the chart. Okay. Now B says define the event A sub I to be the set of outcomes for which the sum of the values of the cards is I, with an ace equal to 1. List the outcomes associated with A sub I for I equals 3 to 19. If you pull a 1, the lowest sum that you're ever going to get is an ace and a 2. That's 3. That's why they start at 3. And the highest is going to be a 9 and a 10 down here. 9 and a 10, that gives you your 19. So what we need to do is define the sum for each of these pairs here. So that's going to equal, we'll just do it this way, do it the easy way. Okay, so we'll get our sum. Now things speed up a little bit. Alright. That's interesting. Okay. So we added the two cards. That's basically it. That's a function of card A and card B, or card 1 and card 2. The function is just to add the numbers. It could be multiply or something else, but we added them. We just added the numbers here. It's like we're playing cards and you win if you have a high pair or something. That's the function A sub I. Okay. What is the probability of obtaining a sum of the two cards equaling from 3 to 19? What is the probability of obtaining a sum of the two cards equaling from 3 to 19? It's saying from 3 to 19, figure out the probability of getting that sum. Okay? Okay. So how do we do this? Okay. How many times can we get 3? There's a 3 here, and there's a 3 here. That's going to be the only 2 3s that you're going to get as far as the sum goes. Okay, let's label this. Okay, and then let's even format it a little bit so your eyes can pick up on it a little bit easier. We'll put it in the simplest form we can. Okay, so now at least it's color coded a little bit. And even to help us even more, we'll center the numbers so that it might be easier on our eyes. Usually is. Put that in there like that. Okay, good. So now we need to, now that we've done the sum, we have to do a frequency table. Okay, so this is a highly defined classic problem where you have a deck of cards and you know all the possibilities. There's nothing left to the imagination. There's no surprises that there's a new kind of card that ends up in the deck that nobody's ever seen before. You know the deck only contains ace through king. Okay? So what we need to do is count how many ways we can get 3. We want to look at the probability of obtaining a sum of the two cards equaling from 3 to 19. So we have to count up the numbers of 3s. So why don't we filter, or let's order this table, okay? So it's actually easier on our eyes a little bit. Okay, so we're going to take all the data that we have right now, and why don't we go into data, and why don't we sort on, okay, let's do that again. Okay, we grab our data, under data we sort, and we want to do column by sum, order it by that, and we'll go smallest to largest, fine. Okay. So we just ordered this. We just reordered this automatically with the data. Okay, it's not automatic. It came out of our brain and we figured it out, right? But what you're seeing is the increasing sums now. We just reordered the data there. Very common things to be doing with your data. And if you see the sum goes all the way out to 19, there's a couple combos that give us 19, a couple 18, but all of a sudden the ways of getting 17 increase. So the probability of getting a 17, a pair that equals 17, is higher because you have more possibilities than if you were looking for an 18. So if you're doing a little betting, you're going to bet on the high probability. And somewhere in the middle here, we have ways of getting 11 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways of getting 11. Okay. The total number of combinations that we have would be, let's see what line we go down to. Let's just do a simple subtraction here. We go down to 93, subtract 3. We have 90 pairs here. Just keep that in mind. That's just a note here. There's 90 ways of getting these pairs. There's 90 different pairs here. Okay. But now what we need to do is do the relative frequency. Okay. Now, how are we going to do that? We know that the sums range from 3 to 19. And what we're going to do is count the relative frequencies of each of those. Okay? We'll call it the value. There's already the sum over here. We'll call that the value. How many times can we get that? Why don't we just use an equals to a COUNTIF. COUNTIF somewhere in this range, somewhere in this data here, count how many times the number 3 appears. Okay? And what we'll do is we'll just use that cell to reference it. Okay? And what we're going to do is make these absolute addresses by using the F4 function. That gives you that. Okay. So there's, just as a check, we know relative frequency of the value of 3 is twice. Now we can just run this down, and what you can see is, remember we counted 10 11s? 11's about in the middle of the pack. It kind of means that you have a lot of crossings here that could end up adding to 11. There's a lot more combinations that could end up there. Okay. So that is, so far, the relative frequency that ends up there. And the total number, remember, was 90. Let's put the number in there, right there. Okay. So the probability of pulling a value of 2 is 2 out of 90. So we're going to say this is going to equal 2 over this cell here, right? And what we're going to do, of course, is run back in here and make that absolute. A couple different ways to do that, but F4 works. Okay. We'll do it by hand. Okay, and then why don't we add up the probabilities here, just as a check, to make sure all these work. And it equals to 1. Yeah, that's wonderful. Okay, why don't we format that so it looks a little bit better. And we'll put it in terms of number with 2 decimal places. Now let's go more than that. We'd like to show more than those 2 decimal places. We'll go 4. Okay. Okay. Why don't we chart this? Okay. Why don't we take a look at what the distribution looks like? So this is going to be a distribution function that we have here. Okay. So we'll do an insert of a. Let's use column. Let's use column here, and there we have it. Okay. So that looks pretty good. What we're going to do is adjust the format the data series. Now we're going to select the data, and what I want to do here is create the labels down here correctly. So we're going to edit over here, and it access the axis label range. We're going to put the labels as the values corresponding to those probabilities. And when we did that, now that this is the probability of pulling a 3, 2 cards that equal 3 is just a little bit more than 0.02, like 2%. Okay, it's a very low percentage, right? And we have the series name correctly as probability, chart name is probability, and we can see that there's kind of pairings here. You know, there's a couple numbers next to each other. It's equally likely to get a 3 as a 4, but then equally likely to get a 5 as a 6, it's interesting just to look at the data as to what happens there. Okay? And those are the relative probabilities, and that is your solution.